Okay, so here we have another topic related to thermal physics, and this one is basically what happens to the molecules of things and what happens to things when you heat them up. And basically the answer is they expand. Most things, most of the time, if you heat them up, they're going to expand. There's one major exception to that, and that's water, but we'll talk about that later. Probably in its own video, we'll talk about how water is unique. But for now, we're going to talk about, in general, for basically everything except water, this is what happens. Alright, when you heat stuff up or cool it down, of course, when you cool it down, the opposite happens. So, what are we looking at here? We have just I've just got a little diagram, a model of salt, table salt, sodium chloride. So this is what it might look like if we could see it close up. Obviously it wouldn't have these colors, but you'd have chlorine atoms, which are bigger than sodium atoms, and that might... Did I do that right? It might be the other way around. Anyways, one of these is chlorines and one of these is sodiums, and they're going to pack in right next to each other like this, right? So you end up with this solid, and all these molecules are basically touching each other, all these atoms. So if you heat this up, add heat, right? If we add heat, then something's going to happen to these guys. Now, first off, you should know they look like they're all locked in place, but for everything that has any kind of temperature at all, if its temperature is above absolute zero, which is everything in the universe, then it's going to have some vibration at least. So these things are vibrating in place just a little bit. They're bouncing, just vibrating basically in place, and they're bumping into their neighbors. So their neighbors are also vibrating, and eventually, given enough time, all of these things will be vibrating basically the same as each other at the same rate. So the whole thing will be the same temperature. All right. So if you add heat, they vibrate faster. All right. So vibrating faster means now that they're hitting their neighbors harder, they're pushing their neighbors a little bit further away from them. So all of these guys are going to start vibrating faster. They're all going to be bumping harder into their neighbors. So there's going to be a little bit more space between them, and they're going to push each other apart a little bit further. So the whole solid is going to expand just a bit, not a ton, but a little bit. Same thing happens with water, liquids, right? So when liquids are a little bit further apart to start with, but if you add heat, then they get even further apart. They push the particles of each other even further away from each other, and they will spread out. So that makes the volume of the liquid, the volume of this liquid would then increase. All right. So basically atoms and molecules are always vibrating. And if you add heat, they vibrate faster. All right. So when you add, well, there we go. Atoms and molecules vibrate faster when you heat them up. As I was just saying, this causes them to bump into their neighbors, and that makes the atoms or molecules spread out a bit. What kinds of effects can that have? How is that relevant to daily life? Well, it's very relevant to daily life, and it's very relevant to the way people build things. So I've got just a few examples here. This is a bridge. A bridge, and then this right here is part of the bridge with these teeth and this metal thing. Why would they do that? The answer is because in, say this is a part of the world that gets very hot, very cold, in summertime, all of this stuff, all of this solids is going to expand because it gets hotter. It gets hotter, the molecules bump harder against each other, it expands, right? That has to go someplace. So that's what this joint is for. When the concrete gets hot, the joint closes. The teeth come together. When the concrete is really cold, the teeth can separate a bit. They can spread out a bit. Now, we're not talking huge differences, but if you don't have these joints, then the concrete tries to expand. It has nowhere to go, and the only option is that it buckles or breaks, bends, at least bends, and possibly breaks. So these are very important for preventing the structure from breaking. All right, same thing here. Railroad tracks, if you don't put in these kinds of joints, like we were talking about there, you can see this is a joint here. Those are free to slide past each other. If it gets really cold, this can expand, like slide this way, right? If it gets really hot, they can slide this way up to a certain point. So this allows the railroad tracks to expand and contract without warping, without bending, which would be really bad for trains. Trains would derail all the time if it weren't for things like this. Last thing, these bricks. Why would you not put the bricks all right up against each other? Well, the reason is because of expansion. You leave some gaps. You leave gaps between the bricks, and that allows for expansion. It's also very decorative and pretty. Anyway, serves the same purpose. So those are some examples. Now you might wonder, different phases of matter, solids versus liquids versus gases, how is their expansion relative to each other? How does it compare? Well, we'll just sum it up really quick. Basically just tell you, and then we can maybe talk about examples of this in class. Solids expand, but they expand the least of the three states. Obviously, they're already really close together, so they don't expand that much when they're heated, but they do expand. Liquids are already kind of sliding past each other, and there's gaps in there, so liquids expand way more than solids if they are heated. And then gases, of course, they're already filling up their container. If the container can expand, then the gases will expand basically as much as the container allows them to. All right, so gases expand a lot when they're heated, way more. If their container can't expand, then their pressure increases, which we talked about in previous videos. So that's the idea of thermal expansion. Bottom line is that the atoms and the molecules are vibrating continuously. When you add heat, they vibrate more. And that means they bump harder into their neighbors, and they just get kind of wacky and crazy, and kind of like a party, bam, 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 and they push each other further and further apart the hotter they get. And that means that on the big scale, what you can see is that the thing gets bigger. It expands. The actual object is going to get a little bigger, or the actual liquid, or the gas, whatever. If it's heated, it gets bigger. All right, so when things are hot, when things get hotter, they expand. And of course, the vice versa is also true. When things are cooled off, they get smaller. They contract. Okay, that's all I've got for you in this video. Thanks for watching.